For your electric circuit, you need a power supply which kind of pushes electrons through the wires and through the components of your circuit. We start by plugging two wires into the variable voltage output, one in the COM slot and one into the variable voltage slot. The power source is then directly connected to a multimeter, the COMS wire into the COM slot and the wire coming from the variable voltage outlet into the voltage slot of the multimeter. With a dial on the power source, increase the voltage to between 3 and 5 volts. To measure the voltage accurately, the multimeter has to be set to either 6 or 9 volts. In the actual lab, adjust your output closer to 4 rather than 5 volts and do not change the output anymore after this initial setup. Using a wire with a crocodile clip, we now connect a resistor to the power source, and we place the resistor on some wire gauze because it may get quite hot during this experiment. So don't touch it when current is flowing through the resistor. To measure the current in series, the multimeter has to be set to the 10 amps reading, and the wire coming from your resistor has to be plugged into the input of that reads 10 amps on the multimeter. To determine the voltage drop across your resistor, you create a new parallel circuit and you connect your multimeter on top of the existing circuit with two additional wires to the power outlet. And you then set the multimeter reading to 6 or 9 volts again. Use this voltage reading and the measured current to determine the resistance of your resistor. Lastly, we use crocodile clamps again to connect two resistors in series. Again, place both of them on top of a wire gauze because they can heat up quite strongly, and measure the resulting current. Again, the wire that leads to the resistors has to be plugged into the 10 amp outlet to get the appropriate reading. Resistors have a color coding, and here's a coding table that allows you to determine the theoretical resistance of these little resistor elements.